warahmatullahi wabarakatuh, and good day. I'm Dr. Siti Rabiatul Aisyah binti Idris, will be your lecturer for today's lecture. So basically this is lecture number 1 after introduction, and today we are going to learn on a topic under CO1 with the title of analysis for stress and strain problems in structural members under axial loading. The objectives of this subject is that to understand the concept of stress, of normal and shear stress. Number 2, analyze and design of members subjected to axial load or shear. And for the lesson objectives, at the end of the semester, students should be able to calculate the deformation, strains and stresses of a structural member subjected to simple loading. For example, axial, direct shear, torsion and bending. Number 2, identify the various mechanical properties of common engineering materials. And number 3 is to analyze elastic deflection of a beam. And for today's lecture, we are going to learn on stresses. There are 3 types of stresses, which is normal stress, shear stress and bearing stress. Therefore, after doing some reviewing on statics, then we are going to learn on how to calculate the value of those stresses. So now, let's see the topics. Let's see the content of the topics, which is stress. There are typical engineering structures or examples for to calculate the value of stresses. Every single structures do have its own stresses depending on the design. The value of the stresses, whether it is high or low, depending on the design itself. And therefore, we need to be carefully design of each of the structures. As we know, same as in statics and dynamics, every single body need to be in equilibrium, meaning that total forces need to be equals to 0. The direction of the forces can be acting on various angles on those structures, and therefore we need to summarize all those forces so that we can calculate and we can summarize all the forces in axis, for example, axis Y, X and also Z. The formula for normal stress is sigma equals to F over A or sigma equals to P over A. Whereas for shear stress, the equation equals to tau equals to V over A. V actually represents for shear force forces due to shear. Whereas in normal stress, P represent forces due to axial loading. Again, this is the formula for normal stress, and this is how normal stress being located. Normal stress, by referring to its name itself, normal, which means that the direction of the force itself is perpendicular to the surface area, whereas for shear stress, the direction of the forces is actually parallel to the surface area. So then we need to be careful when we want to choose the area of the forces acting on it, on that body. Now let's look at the applications, other applications or structures under direct tensile stress. For example, cable. So by looking at this cable, the question given is that this lamp with 80 kilogram lamp is supported by 2 rods AB and BC as shown in figure 1. So the question asks you to find the average normal stress in each rod. The value of diameter is given. For BC is 8 mm and AB is 10 mm. So the first step is that you need to draw free body diagram, which is the same as in statics. So from free body diagram, summarize of the forces in x direction equals to 0, and you will get the value equation with FBC and FAB in it, and this one we can consider it as equation number 1. And since there are two types of unknowns there, then we need to find another equation in order to solve this problem. So summarize all the forces in y directions equals to 0, and through this equation we'll get FBC equals to 1.308 times 10 to the power of 3 minus 1.443 FAB, and this one represent as equation number 2. After that, substitute equation 2 into equation 1. From there, you'll get the value of FAB. And after that, substitute the value of FAB into equation number 2. From there, you will get the value of FBC, which is equals to 359.309 Newton. And we know that the value of stress, the equation of stress is that sigma equals to P over A. P represent the axial stress, axial force acting on that area. So by substituting into this formula, because the question asks you to find the value of stress in rod AB and rod BC, and therefore for stress in rod AB equals to FAB divided by area of AB, and substitute all the information into the formula, you will get the value of stress in rod AB equals to 8.053 megapascal. Same goes to stress in rod BC. Just substitute the value that have been obtained from the calculation, and you will get the value of stress in BC equals to 7.864 megapascal. And this is the other example of structures under direct compressive stress. You can see the direction of the normal stress on this structure. Now let's move on to example number 2. As we refer to example number 2, members AC is subjected to a force of 3 kilonewton, and the question asks you to find the value of X, or the position of X, so that the average compressive stress at smooth support C is equal to average tensile stress in the tie rod AB. The thought has a cross-sectional area of 400 mm square, and the contact area at C is 650 mm square. By right, through this question, you do not need to find the value of area because it is already given to you. So, how to solve this problem? As usual, the first step is that you need to draw a free body diagram. By referring to the figure on your right hand side, this is a free body diagram for this structure. So by referring to this free body diagram, we know that there are two unknowns in that free body diagram, and therefore we need to find that reaction force first. So from free body diagram, let's find the total forces in y direction equals to 0. So in this direction, you will get equation number 1. And again, since there are two types of unknown in this equation, then we need to have another equation in order to solve this problem. So by taking a moment at point A equals to 0, and you will get equation number 2. After that, by looking at this equation, there are 3 unknowns in this equation, and therefore we need to have at least 3 equations. Where can we get that equations? If you notice just now in our equation, there's the value of stresses given, whereby the value of stress in AB equals to value of stress in C. And therefore, just substitute the formula with sigma equals to P over A or F over A for AB and FC. And then from there, you'll get another equation, equation number 3. And after that, substitute equation number 3 into equation number 1. From there, you will get the value of FAB. After that, substitute the value of FAB into equation number 3. Then you'll get the value of FC. And since we are going to find the value of X there, therefore, once you get the value of FC there, substitute it into equation number 2. Sorry for the mistake. Substitute FC into equation number 2. And you'll get the value of X equals to 0.24 meter. By right, in logic, the value of X itself need to be in between 0 and 0.2. Otherwise, the beam itself will not be stable. With that, I thank you very much for your kind attention and cooperation, and see you again in the next lecture. Thank you and bye-bye.